Is the positive integer x divisible by each integer from 2 through 6? So is x divisible by 2, 3, 4, 5, and 6? Okay. So if we want to determine what x is divisible by, the surefire way to determine everything that is x contains, all of the factors that x contains, is to break things up into their prime factors. So our first statement says x is equal to 10m, where m is a positive integer divisible by each integer from 2 through 5. So what does that mean? So x equals, so x contains, and then so we could break our 10 up, so x contains a 2 and a 5. And then what else does it say? So m is divisible by 2 through 5. So m has to contain a 2. M has to contain a 3. Now to be divisible by 4, doesn't have to contain 4. It has to just contain one more 2, because we already have a 2. Then to be divisible by 5, we need a 5. So x, at a minimum, has to contain all of these things. So is x divisible by all of these numbers? So x, is x divisible by 2? Yes, we have plenty of 2's. Is x divisible by 3? Yes, we have a 3 here. Is x divisible by 4? Yep, we just need 2 2's to be divisible by 4. Is x divisible by 5? Yes, we got 2 5's. And is x divisible by 6? And 6, we just need 1 2 and 1 3. And we already determined we have both of those. So this statement here should be sufficient. 10x is equal to n, where n is a positive integer, divisible by each integer from 2 through 9. Okay, so what is this saying? So this is saying 2 times 5 times x is equal to, and so what does n have to contain? N has to be divisible by 2, so it needs a 2. It has to be divisible by 3, so we need a 3. It's got to be divisible by 4, so we need another 2. It needs to be divisible by 5, so we need a 5. It's divisible by 6, but we already have our 2 and our 3, so nothing new needs to be added. It's got to be divisible by 7, which we don't have. It's got to be divisible by 8, so 8 is really just 3 2's. We already have 2 2's, so we just need one additional 2. And then it's going to be divisible by 9, and 9 contains 2 3's, so we already have 1 3, so we just got to add another 3. So our left side and our right side need to match. They have to contain all of the same factors. So on our left side, we already have a 2 and a 5. So those don't necessarily have to come from the x. In other words, we can divide each side by 2 and each side by 5. So 1 2 and 1 5, so it gets eliminated here. And we're just left with what our x contains. So we want to know, is x, does x have to be divisible by all these numbers? So is x divisible by 2? And I'll do this one on the bottom here. So yes, we still have a 2. Does x have to be divisible by 3? Yes, we still have 2 3's. What about 4? So we have 2 2's, so x will be divisible by 4. Then what about 5? Our 5 doesn't necessarily have to come from our x, because it could have come from our 10 over here. So x does not necessarily have to contain a 5, so we do not know if it's divisible by all our integers from 2 through 6. Note that it isn't going to be divisible by 6, because we have our 2 and our 3. So it really comes down to the 5, and not that x doesn't contain a 5. It's, we don't know if it contains a 5. It doesn't have to contain a 5. So the second statement is insufficient. A is our answer.